Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this, it says 8 a.m. every Thursday, and that's 8 a.m. London time. Unfortunately, I've gone a little bit early today, and I know I'm always going early these days, and it's just because the schedules are just so sort of packed. But it is recorded, so hopefully if you can't attend live, you are able to watch this recording later on. I'm going to go straight into it because obviously time is of the essence. So don't forget our ZP Academy. ZP Academy is due for a bit more of a facelift soon, but the ZP Academy does exist. There is free information there's at least 2 free courses that are worth having a look at there. Don't forget our webinars. I will talk about that. We do weekly webinars, which are more kind of 30-minute, not really showing technology, but discussing technology. But we do some monthly webinars, and I'll talk about that shortly. Collaborations, we definitely have Horizon grants in process. We definitely have European projects going on at the moment. We definitely have something like 5 PhDs running in the UK at the moment, so collaborations do run on. We do hire. People do ask us about hiring, and I say please just follow us on LinkedIn because that's where the HR department post. We do have our developer zone, and we do have our workshops. And the reason that I made this apology for A, going early, B, I don't think the video quality is going to be the best this morning, and I don't think the sound is quite as good as I'd like it, and that's because actually we're doing a workshop this week in Grenoble in France. So if you see a link pop up, I've already put the links underneath the video. We have this one this week in Grenoble. We do have another one in November in Norway, and that will be a 2-day workshop. These are really excellent workshops. I'm very proud of the work, and also really appreciate the attendanship because we learn a lot from the people who come on these workshops. So thank you very much. We did have our Scandinavia Sensor Summit that has come and gone, but that means we also have 2 more S-Cubed events happening, one in the UK, which will be around the commercialization of electrochemical biosensors, and there will be one in Norway, which is around the themes of precision agriculture. There is early bird registration for S-Cubed in the UK, so I just want people to save the dates, and with the UK one, you can actually also register as well. Also, I said earlier on that we do much more extensive webinars monthly. So there is one on, there will be one on Julie. Julie is not mentioned much today. In fact, no, it is mentioned today because Julie is a free cloud data management system specifically designed for electrochemical data. It definitely answers the question, where is my data? It's, we put all our data in Julie, and you'll see some of our use of Julie today. We're also doing a webinar on Sense It All. Sense It All is really a really good way of going from from ideas to products. So it's very good for commercialization. If you follow us on social media, there'll be a really big announcement on the 16th of October, so watch out for that. We're also doing a webinar with our colleagues Technando in India, data science and biosensor developers, and we're also doing our monthly FoodSense demo. So FoodSense is really a system for measuring the quality in food production. In particular, it's very good for ginger and garlic. All of these webinars I'm discussing are free. There's, if you attend them all, there's 4 hours worth of content there. But to be honest with you, I really think they're excellent. I mean, we put something like 5 engineers onto the webinar in Julie, so these things are definitely worth your attending. Here's a link, and you can sign up for it. I'll try and go a bit quicker. So the whole purpose of these webinars really is to answer questions that have come in during the week. So I'm going to do an update on the single-purpose biosensor circuit. So the single-purpose biosensor circuit is really intended for people who have a bit of a programming/electronics background. They can engage with this, and also for companies who are looking to commercialize. It's not, if you're looking for a low-cost potentiostat, this is not that device. What makes a potentiostat is software plus hardware. This is much more of a kind of hardware platform, and is not intended for you to, it won't have the kind of flexibility that you're looking for if you're wanting to do fundamental electrochemical development. Anyway, I'll talk about it, and I won't talk about it here. Question here, I've had a couple of emails from the same person on this, and we did say we'd cover it in this workshop, is do the hypervalue screen printed electrodes fit with a MetrOhm DropSens portable potentiostat socket? The quick answer, they do, but I will give a lot more detail in this webinar about that, so please wait for that. I am going to talk about gold screen printed electrodes. I'm going to talk about, historically, we've had something called the 101 and the 10B. They're pretty good. The price of gold has just spiraled over the years, so I want to talk about the impact of gold on the academic community using gold as a screen printed electrode substrate, but I will cover that in detail. And I also talk about our SPE, our screen printed electrode reproducibility. It is important. So I go a little bit quicker now. Question number 1. So we're really on generation 2 now of our single purpose biosensor circuit. Generation 2 is physically different. I mean, there's a lot more shielding around the circuits, so that essentially the noise is lower, and I've updated the, the engineers have actually updated the web page on that. So the single purpose biosensor circuit is really intended for people who have an electronics or / electronics plus programming background, because you do need to be a bit of an engineer to engage with this. And it's really intended for people who are really making products, and it's not really a conduit for low cost potentiostats. But I do want to put a link to that. It is becoming increasingly popular, and you can find information about that. So I've got a particular inquirer who wants to make his own. Essentially, he's an electronics engineer. I've been guiding him with this, and we've just done a generation 2 release. So I would like you to take a look at that. And as I say, it's physically different because there's a lot more shielding involved now. The other question that's come in this week is, will ZP's hypervalue, or will our screen printed electrodes connect to the MetrOhm Autolab or DropSens potentiostat? So just out of interest, MetrOhm bought a company called Autolab probably 2 decades ago, so quite a long time ago. And MetrOhm also owned DropSens as well. And so I will talk about how ZP screen printed electrodes can connect to these 2 brands. So the background to this is our hypervalue carbon electrode. I would say it's easily one of the world's best selling screen printed electrodes into the R&D market. It's also the best quality, but that will also be covered in part 4 of this. The reason I've zoomed in on this is just to say that the pitch that we use at ZP, this 2.54 millimeters, in fact I've got some notes on it here, means that that's the same pitch that on a palm sense potentiostat they have connectors. They use the same pitch. DropSens use the same pitch. So there's a little bit of a standardization in the industry that we're all using the same pitch. I realized I didn't put it here, but we also use the same sequence of electrodes. So this is the reference electrode, this is the working electrode, and this is the counter electrode. And that's exactly the same pattern that palm sensor are using, and also the same pattern that DropSens are using. So I just want you to say that kind of, between those 3 companies, there's never been a meeting over this. This is just something that we've kind of ended up adopting, and we're not going to break that because then it allows for interoperability. Our hypervalue electrodes are 7 millimeters across, whereas DropSens tend to do things that are 10 millimeters across. The problem with 10 millimeter diameters is when you really try to scale these products up, they're inherently bigger. It's just simply not cost efficient to scale up those size of electrodes. They might be quite nice in the lab. I'm not even sure they're that nice in the lab, but the problem is it doesn't scale well in manufacturing. So ZP is quite different, even though we are, obviously we provide screen printed electrodes to the academic community. We try to make them as best as we can. And in fact, I think they're really quite good. But obviously, in our own minds, we want everyone in the end to become a business. And so we're thinking much further ahead than just the R&D. We're thinking about the manufacturing as well. So these are 7 millimeters ahead across, which means they will slot into the palm sense connectors or the DropSens connectors, whether you get them from the Autolab range or the DropSens range, that we will slot into them. But there will be this kind of 1.5 millimeter gap at either end. So you will actually end up sliding around in there a bit. So we will slot in and we will, but just know that you've got to really be careful on the alignment. Now what I'm going to say here is actually we do our own connectors, which you can use with those potentiostats. So let me go forward a little bit. Maybe I should make one more comment as well, that the thickness of these, there's a data, not a data sheet, there's an engineering drawing in a minute, and you will find out that these things are about 300 micrometers thick. So these will slot into those connectors from those two companies. So we're 7 millimeters or 7.2 millimeters wide. We're 25 millimeters or 26.3, got to be precise now, millimeters long, and we're 300 micrometers or 0.3 millimeters thick. So these will connect, these will slot into PalmSense connectors and also Autolab connectors. But I can also show you that you really need to get a ZP connector, and I'll show you all that. What you need to do is you need to look at your potentiostat and say, right, my potentiostat probably has banana plugs on it. If you've got this potentiostat from PalmSense, then those banana plug connectors are probably 2 millimeters in diameter. And if you're using an Autolab, they're probably 4 millimeters in diameter. But you have to measure those because I can't physically see what you've got. The reason I bring that up is because we need to get between those banana plugs and, for example, a ZP screen printed electrodes, and that's what the connector obviously is for. So if you're a 2 millimeter banana plug, then you need what we call the sort of 7 millimeter SPE to 2 millimeter banana plug connector. I will put a link to this in a minute, and the link will also be underneath the video. But that's what you would need, and here's a link to it. If you've got 4 millimeter banana plugs, then you need the 7 millimeter SPE to 4 millimeter banana plugs, and I've put a link to that. So I just want you to be assured that what I'm really showing you is the glue between ZP SPEs, ZP screen printed electrodes, and your potentiostat. And so you just have to answer the question, do I have a 2 millimeter banana plug or 4 millimeter banana plug? In question 4 here, I'll talk about reproducibility, because you might ask yourself, why should I even change? And I will talk about really its reproducibility, which is in question 4. But also in question 3 as well, there's a big discussion on cost. And I think you should really take a consideration of that. If you have poor connection, this is some work that we did a long time ago when we were developing the connectors. We gave somebody some of our screen printed electrodes. We knew they were excellent. They were actually getting, they wanted these results, but they were getting these results. So the problem with poor connection is it will distort your, for example, your cyclovoltammetry. I'm sure this inquirer knows this, but this is the flipping problem. So ZP will obviously support our own connectors, but if you're having a problem with that Autolab connector or that PalmSense connector, we cannot support you. That's, because we didn't make the product. All we know is, and this is a really important point, we absolutely have really tested that batch of screen printed electrodes before you even get them. I'll give you an anecdote actually. I was talking to a client the other day, and the client said, well, what's your reproducibility? And I'll show it you in some notes in a minute, that our reproducibility on these screen printed electrodes is about 5%. I think this is unheard of and he said, no, we're testing, it's 50%. But I said, no. Your experiment has a reproducibility of 50%, but the underlying screen printed electrodes is 5%. And actually, I'll prove that to you. And since then, because we gave him some guidance, he's also agreeing with us. So, I do have other people, once they've received some guidance, they understand, no, ZP's reproducibility and screen printed electrodes, it is up there. And I've got lots of notes on that today. Now, question 3 is about gold electrodes. So I have one of our first clients, very grateful to them, in Indonesia. He's a user of our gold electrodes, so I want to address them directly this morning. Historically, we made gold electrodes, and I've got them here. We've sort of gone away from some of these gold electrodes, and I'll give you a reason why. It's the cost of gold, and these electrodes are simply too big. Now, what I mean by that is the width of these electrodes is something like 70 millimeters, not 70 millimeters. The width of them is 10 millimeters, and the length is about 30 millimeters. They're physically quite big. And I know I've said it already, but bigness is a problem when you're trying to get a lower cost of product. So these have been sort of, quite popular over the years, and in fact, we still make them available. The problem we make them available, but in quite large batch sizes. We do make these materials available in smaller batch sizes, and I will talk about that. These are still good electrodes. It's just the price of gold is making things like this sort of uneconomical. And again, because ZP is always imagining that even our academic clients, somebody's going to come out of that lab one day, a postdoc, and want to set up a business. They need to be using materials that we think we can scale and make them low cost. Here's the links to those various products, but let me go forward with my some comments. So this is the price of gold per ounce over the years. So at one point it was $1,200 per ounce, and today it's actually more like $2,000 per ounce. This is the problem that's happening with gold electrodes, and I'm going to talk more about this in a minute. But this is the fundamental underlying issue that in the last over a space of 2 years, the price of gold more or less doubled, and that's just the raw gold, let alone by the time people have actually processed it up. So at the moment, we make these sort of larger gold disc electrodes. We make them available in pack sizes of 3,000, but it's therefore, so you get them for approximately 2 point something euros each, but you need to buy quite large pack sizes. Now we do make those materials also available in this smaller size. We call it the 303, and I'll just check here. If we give you a pack of 40, then we make them available for 420 euros. We will do smaller pack sizes, but with these days now we do them on the 303. The difference between the difference between the 101s on the far left and the 303s in the middle is simply size. That the 303s are physically 60% smaller. So we literally preserve gold, and also means that our manufacturing rate is higher, so that we can actually manufacture these more frequently. We can pass on the costs, on the savings rather. So the 101 is a bit of something that we've historically had, but we've sort of blended down to something a bit smaller. So you can still get the 101s from ZP, it's just in larger pack sizes, and the 303s are something that we can give in smaller pack sizes. I just want you to note that 420 euros for 40 for 420 euros means they're about 10 euros each. And it's really the underlying price of gold, but the materials on these two electrodes, at least that gold material, is identical. So you can sort of transition from that 101 to this 303. And what we're really doing then is actually transitioning people over really onto our hypervalue range of electrodes. So we do have a hypervalue range of gold electrodes, and there we're making a pack of 100 available for 625 euros. So that's about 6.25 euros per electrode. I'm going to make a big comment about gold in a minute and actually say that even if you're doing R&D, I would actually suggest that you start going on to carbon, and I'll give you the fundamental underlying economics of this. But again, if you're interested in the hypervalue gold electrodes, I've put the links underneath the videos as well. So this is a side note. So at ZP we use gold and we use carbon. If I'm given the liberty, I will actually use carbon in our programs because of the price of gold. So I've put some links here. Hopefully I have pasted them. So the person that I'm addressing today, they're very used to making these self-assembled monolayers. And it's nice, easy chemistry, and it essentially works. And we do use our gold 303s quite a bit, doing impedance spectroscopy, and we get really nice data. So I can definitely back up the statement that the gold 303 is a good material for people making self-assembled monolayers, for doing things like immunoassays, and ZP does it all the time. And even these electrodes, here we're obviously using the Nyquist plot. This person I'm addressing has a lot of experience in impedance spectroscopy, so they will understand this data. But what I would say is, I would say to every academic, start thinking about replacing gold and platinum in your electrochemical biosensor work with carbon. ZP has been using carbon for years. Our carbon electrodes are really good. They're really low cost. And when I say good, they're really reproducible. We use things like pyrene NHS to actually functionalize that surface and make that surface active, and then we can bond antibodies to it. We often use something like chitosan as the blocking agent. We often follow these this functionalization steps with cyclovoltammetry so we can see that it's working. And then here we actually use differential pulse voltammetry to look at the binding assay, though I would say impedance spectroscopy would work just as well and square wave voltammetry would work just as well. So the only reason I brought this paper up and these slides up is just to sort of make this plea that there's no real reason why you can't actually go over to carbon. People do ask me questions like, well, you know, do I have a better limit of detection with gold versus carbon? I don't really think so. I see it in the literature sometimes, but in the literature, the problem that people have is really reproducibility. So the limit of detection that they kind of talk about is actually, their biggest problem is actually reproducibility and fabrication. It's not the materials, whether it's gold or carbon, it's actually their own lab's reproducibility. But for us, we use carbon all the time and it works really well. The reason I bring this up is now, as our hypervalue gold electrodes, it's 625 euros for 100. Whereas with our hypervalue carbon electrodes, it's 250 euros for 300. So it is essentially less than €1 each. I understand that people have a tradition and a lab tradition of using things like gold. You can still buy our 101 golds. It's just they're in large pack sizes. If you want to stick with the same gold material and go onto the 303, if you want to stay on gold but get the price down, then go onto our hypervalue gold. But if you really want to get the price down, and I would actually, you know, essentially ZP makes less money, but we like to give the straight answer. I would use the hypervalue carbon electrodes and start changing the coupling chemistry so that actually you can use carbon. I should say I probably already put that link underneath the video as well. So my advice is based on this, that look, at the moment it's probably about 2,000 US dollars per ounce, which is really not much material and very a lot. Whereas the carbon prices are something like 1,250 US dollars per ton. So there's 32,000 ounces, I think, in a ton. So it's something like 32,000 times cheaper is graphite or / carbon than gold, and that's the underlying economics of it. So, you know, electrochemistry, electrochemical sensor development is, in the end, is quite a practical science. You know, we're trying to solve practical problems. We have to understand that we can't build assays on top of gold. It's 2,100 US dollars per ton. Per ounce. Whereas carbon is, you know, 1,250 US dollars per ton. 32,000 ounces in a ton. People have to really look at this materials cost and say, okay, I'm going to have to go over to carbon. So my advice is, unfortunately, go over to carbon, go over to the hypervalue carbon electrode. Now this person, one of our longest clients, they do have an Anapot EIS, so they're good. I would recommend trying out some hypervalue carbon electrodes. They already have a cable, but if you buy the Anapot EIS, make sure that you get this cable that I'm linking to here. And also the connector, and the connector comes back to question 1 earlier on. If you have another brand of potentiostat to get between your potentiostat and our ZP electrodes, you need a connector. Just on reproducibility, if you attend one of our webinars, and at the beginning of this, I did link to I linked to a page and said, look, we're going to have something like 4 free webinars where we do live demonstrations. If you watch one of our webinars, either on Sense It All or on Food Sense, you will see us performing live demonstrations. And what you'll notice is we just do them live, okay, and we don't do any calibration when we're doing this work. And that's because the underlying ZP screen printed electrodes are the most reproducible electrodes in the world. And why is that? Because ZP is the only manufacturer of screen printed electrodes that, you know, sells into the R&D market that actually uses their own electrodes in their own products. So we really have to have good quality of our screen printed electrodes. Otherwise, our products like FoodSense will not work. So there's a real embedded reason why we have to really get reproducibility. And that means that we can actually then be calibration free. So when you see these kind of demos, we always get excellent results because we know we have to be trusting that screen printed electrode is going to actually be really reproducible. Now, so we need that quality. Now, how do we achieve that quality? We achieve it really by doing a lot of testing. So there's very little testing that's really happening in the world of screen printed electrodes. People are just making them and shipping them. At ZP, we at least do some electrochemical testing to make sure. So we would take sheet 1, we would test it. So we're doing a whole run of a lot of sheets, and we would actually test them. And if we see that a few of the electrodes are not passing, then we will fail it and throw out the entire sheet. And that often happens on sheet 1, because sheet 1's the first sheet that you essentially print, and that's when you're kind of setting up the machine. So you often sacrifice sheet 1. Then we test another sheet in the run, then another sheet in the run, and then another sheet in the run. All this data, by the way, is going up to Julie. So today I haven't mentioned Julie, but I have said to you there's a webinar. There's 4 free webinars, and one of them is on Julie. So look in the links underneath the video, come to that webinar, and you'll see Julie. So we're able to do a lot of mass testing and then a lot of analysis. And we make sure that our errors are actually acceptable and actually quite small. So here I can see that we've got a sheet, relative standard deviation of 6%, 5%, 6%, 6%. So this is the bit where I'm saying that our sheet-to-sheet variability or electrode-to-electrode variability is not 50%. No, these are single-digit percentages, and we put a lot of effort into this because we need it in our own products. So if you look at when we're developing assays, for example, we'll test the concentration of the analyte of interest, and then we can see that actually we can easily do this kind of resolution on concentration because actually the electrodes are really reproducible. So each one of these data sets here is in triplicate, 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 triplicate. 1, 2, 3. There's about 15 to 18 sensors being tested in this particular experiment so that we can get our calibration curve. Fundamentally, what allows us to do this quite quickly is the fact that we don't have electrodes that are irreproducible. Otherwise, we wouldn't be able to get such a nice calibration curve. So, question number 1 is, we have now gone to a generation 2 single-purpose biosensor circuit. This is really for electronic engineers, coding engineers, and companies that are really trying to make their own products. So we call that an OEM, an original equipment manufacturing solution. It's not really for the potential. It's definitely not for people who are doing R&D in the lab where you need to make a lot of parameter changes. Our hypervalue screen printed electrodes do work with MetrOhm, DropSens, but I have shown you that you have to look at your banana plug size and find the appropriate connector from ZP, and I have put links to that. The gold screen printed electrodes, sure, we do those electrodes even now. It's simply that the price of gold means that it's actually quite hard these days to make gold electrodes and to be able to provide them at reasonable pricing. At that position, I don't think is ever going to change. The gold is never going to come down so much in price because people like gold. People use gold in many applications. Whereas, to be honest with you, graphite is just not held. You don't have a jewelry market that's scrambling to get hold of gold. You don't have, people holding gold bar or gold bullion, as a way of preserving wealth. It's just not that kind of material. So I would suggest that, you can still get gold electrodes from ZP, but I would actually even say that I would never develop, if I had the choice, an electrode on gold. And whether it's gold or carbon at ZP, we do make a really big effort to get reproducibility. So I think I've all finished there and say thank you. I'm not even sure how long this has been going on for, but it probably feels like 30 to 40 minutes, so my apologies for that. But if you have any questions on ZP, the next webinar is already booked in. It's on the 12th of October, 2023. And so, yes, every week we do a webinar answering technical questions that have come in during the week. Okay, thanks very much. Take care.